In designing Firebird 3, our job at styling is to integrate the new developments of research and engineering into a fully operational, eye-appealing car. We start with a man, Oscar, and design the car around him. Basically, we need a passenger capsule and a power package. By putting a control stick here, at Oscar's side, we could develop a new means of entry and give Oscar a semi-reclining seat to put him in the most comfortable driving position. For the power package, we decided to put the latest research gas turbine engine here, behind the passengers, and simplify the powertrain. We knew, too, that the accessory load would be high. So to run the generator, pumps, and other equipment efficiently at a constant speed, we use a small piston engine. This allowed us to unify the accessories in the best available space. Then the arrangement of these elements is checked to assure satisfactory weight distribution.
We start with basic theme sketches, preliminary ideas that help us over the first formative stages of design. Then, we translate these sketches into side views of the car, using these fluid lines of colored yarn to work out the various combinations of curves. Change only a pin, and in an instant, we can change the entire character of the car. In this way, we arrived at the basic silhouette of Firebird 3.
Many original engineering features have been incorporated into this chassis. The frame, for example, with its rigid spine and wishbone construction to accommodate the passenger and engine arrangement, and the unique front axle and steering mechanism made possible by this fully powered control. Unicontrol is a new concept in steering, designed to simplify your driving task. This system uses specially developed electronic computers to control hydraulic power servos which actuate the brakes, throttle, and steering. Push forward to accelerate, steer left or right. Pull back for braking. Rotation of the control knob selects forward, reverse, or park. There is no mechanical connection between the control knob and the front wheels, but car motion feedback is supplied to the driver by the mass of the knob. To this, we have also added auto guide, an automatic guidance system, and cruise control. The coils receive signals that are fed to the steering system computer in the electronic control and electric power center. The electrical signals are converted into hydraulic power at this servo valve manifold to guide the car along its course. Electrical and hydraulic power for all of the controls and accessories is provided by this small accessory drive engine, a significant development of both the research and engineering staffs. This test shows how cooling air enters the hub and is forced through a series of air cooling passages. This brake mechanism and a new anti-skid device gives unsurpassed driving security. To give Firebird 3 a smoother ride and better roadability, the research laboratories have designed a high-pressure air oil suspension system in which the front and rear springs are interconnected to suppress pitching motions of the car. The regenerator, consisting of metal mesh drums, salvages most of the heat in the exhaust gas and returns it to preheat the incoming compressed air.
Tests at the General Motors Desert Proving Ground in Arizona. Tests to prove out the forward-looking designs, the ideas embodied in this experiment on wheels. Squeeze your sonic key, and sound waves open the door. The sonic key is also used to start the car. First, the small accessory engine. Then, the gas turbine. Brake flaps provide additional braking. You're ready now for the driving thrill of a lifetime. Want to sit back and relax? Well then, set in the speed you want to drive and switch over to automatic guidance. Release the stick, and Firebird 3 is on its own, receiving its commands from a wire in the road.